This section of my talk on the number e is going to focus on calculus. Calculus studies, at least in part, rates of change. The number e and the exponential function y equals e to the x are central to the mathematics of calculus, perhaps in ways that are not readily apparent or even not yet discovered. Okay, so we're going to start by discussing the derivative of f of x equals b to the x for some base b. Okay, and this is the definition of the limit. So if we apply this definition to the function f of x equals b to the x, we are going to get this expression, b to the x plus delta x minus b to the x all over delta x, as delta x finds its limit at 0. And this expression, of course, is equivalent to this expression given the property of exponents. And we can factor out b of x, right, and get this expression. And finally, we can factor out the b of x outside of the limit and get this expression. And this is the derivative of b to the x. And so the derivative of b to the x is b to the x times this number, which I assure you is a constant. So in other words, the derivative of the function y equals b to the x is k times b to the x for some constant. And so the function b to the x is proportional to its own derivative. Okay. So this leads into the question, is there a value for b that is more natural? What I mean is there a value of b such that that quantity is equal to 1? That is there a value of b such that this equals 1 so that b to the x is its own derivative? Okay. So, I'm not going to do the complete proof, but I am going to demonstrate a kind of an outline of the proof in order to find the value of b such that this expression equals 1 as delta x goes to 0. Okay? So we're going to find b, right? Well, we use algebra to obtain this expression, right, by multiplying delta x by both sides. So b to the delta x minus 1 equals delta x. And I'm going to add 1 on both sides, so we get b to the delta x equals delta x plus 1. And I am going to take the delta x root on both sides. In other words, I'm going to take both sides to the power of 1 over delta x. And so I get this, right? So now we want to find 1 plus delta x to the power of 1 over delta x as delta x finds its way to 0, and this is the value of b. Okay, so there's a kind of a transformation we're going to do, and this is a really sloppy proof. In fact, it's not a rigorous mathematical proof. It's just a kind of a more intuitive outline of the logic involved in finding these values. Okay, but let's set 1 over delta x equal to h. So as delta x goes to 0, then h goes to infinity. If that's the case, then we can rewrite this expression this way and find 1 plus 1 over h to the power of h as h goes to infinity. Well, we know that that's actually equal to e. And so b equals e. And we have found the natural exponential function. That is, the derivative of e to the x is equal to itself, e to the x. Okay? And this is very important. The derivative of this function is itself. And this is the only function that you're going to find this. This is the only function that such that is its own derivative. In other words, if d of y over d of x equals y, that is, if the derivative of y is itself, then y is going to look like this. Y equals c times e to the x for some constant c. Okay. All right. This ends part 1 of part 3 of my talk on the number e, and I will continue with the inverse of e to the x in the next video.